Well, the question says that there is a function f of x which is x cube plus 2x square plus 5x such that x is less than 0. So we have to find the interval, that means the values of x for which it is concave upwards. Now concave upwards, as the name suggests, it will be somewhat like this, right? Graph opening upwards, mouth opening upwards. And for this we already know that f double dash x should be greater than 0. This much we have learned, right? So we are quickly going to apply that condition and let's find what is the value of x. So when I find its first derivative, my f dash x actually comes out as 3x square plus 4x plus 5. I'm differentiating the function. And when I double differentiate, f double dash x actually is going to come out as 6x plus 4. Clear? Now, since my x is less than 0, they have already mentioned this. And when I take it greater than 0, from here, the value of x comes out as greater than minus 2 by 3. But still, it has to be less than 0 because that is what they have mentioned in the question. So, therefore, I can say that it will be concave up when x lies between minus 2 by 3 to 0. This will be the interval. Understood how we have solved this? Perfect. Well, moving further, here they have asked about point of inflection for the function fx which is equal to x square ln x. Now, what is the point of inflection? The point where concavity changes, right? So, for this point of inflection, f double dash x should be either 0 or it should be not defined and its sign must change about this point. So, this is another important condition for point of inflection to exist. Clear? So to get point of inflection for this fx, I'll find f dash, then I'll find f double dash x and equate it to 0 first of all. Clear? Okay. So let's guys quickly start with the solution part over here. Now to differentiate this function fx, which is actually product of x square and ln x, we'll apply product rule. Clear? So when I do that, I'm going to get f dash x as x square derivative is 2x multiplied by ln x plus ln x derivative is 1 by x, right? So it's coming out as 2x ln x plus x. Now let me differentiate it once again. So when I do that, I'm going to get f double dash x as, again in x and ln x, I'll apply the product rule. So when I differentiate x, it's going to become 2 ln x, and when I differentiate ln x, it's going to become 2x multiplied by 1 by x plus x. Well, that derivative is 1. So finally it's going to come out as 3 plus 2 ln x. Got this much? Okay, so now when I equate it to 0, I'm going to get 2 ln x is equal to minus 3. That means x will be equal to e raised to minus 3 by 2. Clear? So this is the point where f double dash x will be 0. Now further, what I have to make sure is that at this point, sign of f double dash should change, right? So if I take my ln x over here, this is my ln x graph, right? Let's say this point over here is e raised to minus 3 by 2. So we already know that when it is equal to 0, when I have my x value below that, my f double dash will be negative. It is equal to 3 plus 2 ln x, so it will be negative. And if I take my x value greater than this, on this side, my f double dash will become positive. That means my f double dash is changing its sign about this point, e raised to minus 3 by 2. And therefore, this has to be what? It has to be the point of inflection for this function f of x. Understood how we have solved? Guys, do remember for point of inflection, either whenever you make f double dash x as equal to 0 or not defined, whichever point you get, do make sure that sign of f double dash should change about that point. It's really important condition. Understood? Perfect. I hope you'll remember from now on. And if you remember it beforehand, it's superb. Well done. And thus the answer therefore will become D. Well, moving forward, here the question says, what are the set of values of a for which the function fx, which is ax cube by 3 plus a plus 2x square plus a minus 1x plus 2, this possess a negative point of inflection. Now, first of all, what is point of inflection, guys? Point of inflection is the point where concavity of a function changes. This is my point of inflection P, right? On my left hand side, it is concave downwards, and for concave downwards, we know f double dash is less than 0, right? Similarly, on the right side of P, it's concave upwards now, and therefore f double dash will be greater than 0. That means since my f double dash is changing the sign here and it is a cubic function, that means at this point of inflection, first of all, f double dash should be 0. It will be not defined because it's a cubic function, f double dash will be defined everywhere, right? So only condition is that f double dash should be 0 at this point of inflection, as well as it should change the sign, right? And if it is changing the sign, that means at this particular point of inflection, if I find it's one more derivative, on the higher side, that means my f triple dash, it should not be 0, right? Because if it is coming 0, that means f double dash is not going to change the sign. So you have to keep in mind for point of inflection, f double dash is either 0 or not defined, as well as its sign should change. That is the most important condition, right? Okay, so we are going to apply this over here. So first of all, let's find the point of inflection and then we'll put the condition that it is a negative. To get point of inflection, first of all, I have to find f double dash. For that, I'll differentiate it first. So my f dash x is going to become ax square plus twice of a plus 2x plus a minus 1, right? This is my f dash. And now I'll differentiate it once again. So I'm going to get my f double dash x as 2ax plus twice of a plus 2, right? And when I equate it to 0, because I have already told you that for point of inflection, f double dash should be 0. So when I equate to 0, I'm going to get my x value as minus of a plus 2 upon a, right? And this quantity should be negative in sign. That means minus of a plus 2 upon a, this entire quantity should be less than 0. And this we know how to solve, don't we? We'll just multiply by minus sign and mark the critical points on number line, right? So when you multiply by minus sign, the sign of inequality definitely is going to change. And from here, we can write the answer. The critical points are minus 2 and 0. And then it's plus, minus, plus. So if it is greater than 0, I can say that a either should be less than minus 2 or should be greater than 0. So this is the set of values for which f double dash x, wherever it's 0, that value of x will come out as negative. But again, for this to be the point of inflection, what I have to make sure is that f triple dash should not be 0, right? So if I find my f triple dash x, it's going to come out as a constant number, that is 2a. And for these values of a, which I have found in first equation, this will never be equal to 0, right? So if my f triple dash is non-zero, that means f double dash x is going to change its sign, and this will be the valid point of inflection, and that too negative in its value, right? Understood? Perfect. So the final answer, if I write in interval form, it is going to become minus infinity to minus 2 union 0 to infinity. These are the set of values of A for which we are going to get a negative point of inflection. Understood, guys? Perfect. And therefore, the correct option will become A. Well, moving further, here the question says, which of the following functions is concave down over the set of positive real numbers? Over the set of positive real numbers, what do you mean by that? That x is greater than 0, right? So, it is concave down. And what do you mean by concave down? For concave down, we know that f double dash x should be less than 0. So the question says that out of these 4 options, which are those where f double dash will be negative whenever x is a positive real number? Got it? Perfect. So let's start by checking the options. So if I go for first option, first of all, if I have concave down, we already know f double dash should be less than 0. So when I go for my first option and when I differentiate it, first of all, f dash x I have to find out, which is 2 raised to x multiplied by ln 2. We know the derivative of a raised to x, right? Again, when I differentiate, my f double dash x is going to become, again I have to differentiate 2 raised to x. So it's 2 raised to x multiplied by ln 2, and there is one more ln 2. So it's going to become ln 2 whole square, right? Okay. So this is always positive because we already know that ln 2 whole square is a positive quantity, as well as 2 raised to x again is a positive quantity, right? So this is always positive. Therefore, it is not at all concave down. So first option is rejected. Then we'll go for second option. Now in second option, my fx is root x or x raised to half. So when I find my f dash x, it's going to become 1 by 2 x raised to minus 1 by 2. Right? We directly apply the formula for derivative of x raised to n. X raised to n derivative is nothing but n into x raised to n minus 1. Right? Okay. Now further on differentiating, it's going to become 1 by 2 multiplied by minus 1 by 2 x raised to minus 3 by 2. And it's finally coming out as minus 1 by 4 x raised to minus 3 by 2. Now whenever x is positive, I can say that x raised to minus 3 by 2. Well, this quantity will always be positive, but I have a minus sign in front, therefore making the entire f double dash x as less than 0. Right? So my B option has to be one of the correct options where it is concave down. And now we'll check 2 more options. So for C option, my fx is 3x plus 2. So when I differentiate it, I'm going to get my f dash x as 3, which is a constant, and f double dash x will be 0. So this is definitely a linear equation. We'll know the graph. Here we don't decide about concavity or convexity. So again, C is not at all the correct option, leaving behind option D, which is fx is equal to x cube. Now here when I differentiate, I'm going to get my f dash x as 3x square. And further when I differentiate, f double dash x comes out as 6x. Now this will be somewhere positive, somewhere negative. But remember guys, in the question they asked about only the interval when x is greater than 0. And we know that whenever x is positive, this entire f double dash x will always be positive, right? And if it is always positive, again, it does not fall in a required category of concave down. Here for positive, real values of x, graph will be concave up, right? So therefore, only B option, that is fx is equal to root x, will be the graph which will be concave downwards for positive real numbers. Understood? And the correct answer will become B. Moving ahead, here they are saying that what are the set of values of a for which the function fx, which is equal to x raised to 4 plus ax cube plus 3x square by 2 plus 1 will be concave upwards along the entire real line. That means for all real values of x, this graph should always be concave upwards. There should be no change in its concavity, right? Perfect. How are we going to solve this out? Well, this kind of question, guys, do pay attention how we are approaching the question. First of all, it has to be concave upwards. That means f double dash x should be greater than or equal to 0 for all real values of x. And whenever it's equal to 0, we have to keep in mind that its sign does not change around that point, right? So the condition will be that f double dash x should be greater than or equal to 0. So when I put that, first of all, I'll differentiate to find f dash x. So my f dash x is going to become, when I differentiate x raised to 4, it's 4x cube plus ax cube derivative is 3x square. 3x square by 2 derivative is 3x and plus 1 will, that's a constant, its derivative will become 0. Now again, when I differentiate, I'm going to get f double dash x is equal to 12x square plus 6ax plus 3. And it has to be always greater than or equal to 0. Now, this is my f double dash x. It has to be either always positive or it can be 0, but sign should not change. That means if I draw the graph of quadratic, graph can be like this, right? Graph can be totally above x-axis or graph can cut x-axis at 2 points. Now listen to the concept which I'm going to tell you over here. It will be used in many more questions. The questions which are formed like this. For my first case, f double dash x is always positive and it is equal to 0 at one point. Let's say that is alpha, which will be the root of this quadratic, but the sign is not changing, right? And that is pretty important, that f double dash x, if it is equal to 0 at one point, its sign should not change about that point, right? Okay, so this is obviously allowed. That means D can be equal to 0. If I go for the second case, I have quadratic which is totally above x-axis. That means f double dash x will be always positive. Again, this will be allowed, it's concave upwards, right? But if I go for my third case, here my f double dash x actually is changing the sign. And if it is changing the sign, it's becoming 0 at 2 points, let's say alpha and beta, and it is changing the sign. So here will not always have concave upwards. Whenever f double dash x is positive, it will be concave upwards. When it will become negative, it will be concave downwards. So third case has to be rejected, right? And if I combine my first and second case, my first case where D is 0, my second case where D is negative. So when I combine, I can directly say that this has to be greater than or equal to 0 whenever D is less than or equal to 0, right? And now when we apply the condition, when I put the value of A, B and C in this discriminant formula, it becomes B square, that is 36A square minus 4 times of 12 multiplied by 3. It's less than or equal to 0, right? So this 36, 12 and 3 got cancelled, and we know that factors are A minus 2 multiplied by A plus 2. less than or equal to 0. So equality is allowed. And from here we are going to get the value of A belonging to the set -2 to 2. This will be the set of values of A, for which this entire graph will always be concave upwards. Understood? Perfect. And therefore the correct answer will become B.